Thank you. Thank you for this opportunity to present our work. By way of background, the current treatments for stress incontinence do not repair the neuromuscular continence mechanisms, including nerve, muscle, and connective tissue that can be damaged in childbirth and lead to stress incontinence. So in my group, we've been using regenerative approaches in animal models to try to repair these damaged tissues and restore continence. So what we've already observed is that both mesenchymal stem cells and their secretions facilitate recovery in our rat model of stress incontinence, and that independently, brain-derived neurotrophic factor accelerates recovery in this model. And having noted that rat bone marrow-derived mesenchymal stem cells, which is what we use, secrete BDNF, we then hypothesized that BDNF is a key factor in the secretions of mesenchymal stem cells that repairs the neuromuscular continence mechanism and improved continence in the rat model of stress incontinence. Now, we study the secretions of mesenchymal stem cells. We often call it the secretome, the totality of secretions from the stem cells, and we study this as concentrated conditioned media. So we take the media from having cultured the cells, we sort out the cells, and we concentrate that media because it's a large volume. So the aim of this study was to determine if reducing brain-derived neurotrophic factor levels in this concentrated conditioned media from rat bone marrow-derived mesenchymal stem cells reduces the functional anatomical improvements in this rat model of stress incontinence. So our rats received both pudendal nerve crush and vaginal distension, which has become our current standard model, or a sham injury. The sham-injured rats only received a control media that wasn't conditioned by the stem cell secretions. And the injured rats received one of the following, either just the control media or our normal unmanipulated concentrated conditioned media from the rat mesenchymal stem cells containing the secretions, or the concentrated conditioned media from stem cells that were transfected to knock down BDNF, which resulted in approximately 35% decrease. We also had a group of conditioned media from mesenchymal stem cells that were transfected with a scrambled sequence, which did end up knocking down the BDNF to about 75% of the unmanipulated cells. Each rat received 2 intraperitoneal treatments of the treatment group they were in, 1 hour and 1 week after the injury, and then we did functional anatomical assessments 3 weeks after injury. And I'm only showing you a couple of our outcomes for the sake of brevity in this short presentation. One of them is this urethral pressure here, and it's one of our measures of continence function. And what we found, let's see, the mouse works, in our control media group, which was the group that we expected the least amount of regeneration and recovery, it was significantly different from the sham-injured animals, our most normal group. But so was the BDNF knockdown treated group, as we expected, as was the scrambled group, was also significantly different from the sham-injured animals. Both the BDNF knockdown group and the control media group were significantly decreased compared to the animals treated with the unmanipulated conditioned media. And then the other outcome I want to show you is our neuromuscular junction outcome. Green shows the nerves, red is the neuromuscular junction, and blue is the external urethral sphincter. And a normal neuromuscular junction is innervated by a single nerve and compact and small. And this sort of spreading out of the alpha-bungarotoxin in the neuromuscular junction shows a denervated result. And only when they're innervated properly are they compact. So you see 3 weeks after the injury and treatment with the control media, denervated neuromuscular junctions and little nerve regeneration. In the BDNF knockdown group, interestingly, we still see this spreading out of the neuromuscular junctions, but a lot of regenerative efforts with a collateral innervation trying to innervate the neuromuscular junction. The scrambled conditioned media group, we see also oddly shaped and spread out neuromuscular junctions, and our control conditioned media treated group, we again see the compact, best regenerated, and still these collaterals. Eventually the collaterals will die off and one nerve will survive, but this is 3 weeks after. It's sort of a mid-regeneration time point. So in conclusion, our pudendal nerve crush and vaginal distension injury reduces leak point pressure and denervates the external urethral sphincter. Reducing the BDNF in the conditioned media reduces the regenerative effect, but so does transfection of the siRNA, the scrambled, which also reduces the regenerative effect, but not as much. And the regenerative effect of the scrambled was less than we expected with the 75% representation of the BDNF. So we conclude that there's unknown but important proteins that are also involved in the regeneration, and that BDNF is an important factor in the recovery, but not the only one. And we're currently doing proteomics on all of our different conditioned media group, transfected and not, to try and figure out what other molecules were increased or reduced in the process of transfection. So I want to thank my group at the Cleveland Clinic, and particularly Xiaoyi Yuan, who did the majority of this work in collaboration with others in the group. Thank you.
So are there any questions from the audience?
Well, I have one. Do you think that BDNF has a threshold effect, or that theoretically, if you could even increase the amount of it, it would help? You have shown that decreasing is a problem.
Right.
But
So
what about increasing?
In a prior study, we treated the animals with BDNF, and we found a profound regenerative effect. The conditioned media produces a much lower dose of BDNF than we treated with, and we haven't done a dose-response curve, which would be interesting. But at the dose we used, we found systemic effects of the BDNF, even though we treated locally. It's a profound neurotrophic factor. So maybe the conditioned media with the lower doses in the unmanipulated group provides a sufficiency of the threshold for regeneration.
What were the systemic effects?
Sorry?
Which sort of systemic effect have you seen?
Oh, neurogenic effect. So they were eating off their toes.
So Margaret,
Not nice.
So Margaret, you know that BDNF has very positive effects, just like nerve growth factor. Mm-hmm. It is actually the proforms of these neurotrophic factors that tend to be apoptotic. So have you tried blocking, for example, the P75 receptors?
We have not. It's a project we're doing now, not so much to block the receptors, but to add the TrkB receptor and mop up the BDNF, a different sort of angle on blocking. And it would be interesting to do it in the context of the conditioned media. We're doing it right now and sort of proving the concept in the context of our electrical stimulation studies.
Yeah,
but
or
that's
at least if you're going to knock it down, try to have it to the epitope for the mature form. If you can do that, and knock, and then leave the proform, or rather the mature form there for the positive effects.
Okay, good suggestion. Thank you.
Any other questions for the audience? Well, very nice work.